Welcome to the Mesa Robotics Competition 2024. We are the Four Peters.
Our team consists of Christian Antiveros, our driver, Noah Carrillo, our coder, and me, Jorge Escalante, the engineer and the researcher. We are representing Enrique Camarena Junior High. The two competitions we'll be competing in are the Teller Operator Challenge and the Autonomous Challenge.
The Teller Operator Challenge consists of grabbing rings off a multiple level spinning rack and placing them on coordinated poles.
The goal is to reach 20 points, and each color has a different point value. The challenge is difficult as it requires focus and coordination, as you need to get the rings off the rack while other people are also trying to get the rings.
The Autonomous Challenge involves placing 4 rings on a rack and finding a colored strip. This is difficult because you have to code the movement of the robot to complete the challenge.
We explored the 20-point challenge by practicing the movement of grabbing rings and putting them on the rack and putting them on the color-coordinated pole. We practiced this movement many times to get accustomed.
We will now be showing the construction process of the robot. First, we connect the robotic arm to the neck of the robot. We designed this robot after watching the video examples, which helped give us ideas on how to upgrade the original design. Then, we install the backbone of the robot so that the arm can have added stability. We then attach the counterweight to the backbone so that it can stay level to the ground while picking up objects. After installing the previous attachments, we secure the rubber bands to add tension to the arm and neck. This creates better stability and better secures the arm to the neck. Our first design had many issues. It was not very stable and the neck could not do a full 180. It also could not pick things up off the floor.
To fix these problems, we added a counterweight and backbone for stability. We changed the gear position so that the claw was not restrained and could fully go 180. And we extended the claw and neck so that it could fully reach the floor. In real life, robots are used in many important industries. An example of this is in manufacturing.
Manufacturing is the process of turning materials into finished goods.
Robots are used in manufacturing to handle machines, process operations, and to assemble products.
Another example of this is in agriculture. Agriculture is the process of farming, including the growth of crop and raising livestock.
Robots are used in agriculture to harvest crops, pluck weeds, and provide information about their soils, such as moisture and fertility.
And there are many majors that can lead to working with robots, such as majoring in computer engineering, which can get you a career in robotics, as it involves working with data and coding.
Additionally, a degree in mechanical engineering can help get a career in robotics, as it involves training in robotics and the design of robots.
The beginning part of the code tells the robot that when started, it should raise the arm up 5 degrees and turn the color sensor lights on.
Afterwards, the code tells the robot to set the light's power to 100 and sets the font on the brain. This is for when the color sensor detects a color and prints it on the brain.
The next part of the code sets the variable, in this case ring distance, to 0 and repeats the action of picking up the rings and placing them on the pole 4 times.